During the early 1970s, following the conclusion of the Apollo program, the American Space Agency NASA began what became the Space Shuttle program, which was the development of a reusable winged spacecraft that was capable of space flight and flight within the atmosphere like an aircraft and landing on a runway. Previous American spacecraft had returned to Earth via parachute and splashing down in the ocean. Some design studies were being done during the 1960s, and the program officially started in 1972, and the first orbiter, named Enterprise, was rolled out in 1976. Enterprise was designed for initial atmospheric test flights rather than space flights, but still represented a huge leap forward in spaceflight technology and capabilities. Flight tests of Enterprise were conducted in 1977, testing the orbiter's landing capabilities, simulating a return from a space mission. One important design feature of the orbiters was a large payload bay, capable of carrying large satellites or other large items into space. It was this that convinced the Soviets of the potential military uses of the Space Shuttle, including concerns about the shuttle carrying anti-missile laser weapons into space, and even being able to attack Soviet territory directly. This led to the decision that they needed a comparable spacecraft, and thus began the Buran project. While Buran was developed with both military and civilian use in mind, potential military use was explored in great depth, and was developed based on assumptions that the American Space Shuttle would be able to carry nuclear weapons. The project became a major part of Soviet efforts to compete strategically and technologically with the U.S. There are many similarities to the American Space Shuttle, although there are also major differences. Initial design work started in 1974. Research into new rocket technology started, as well as an extensive espionage effort by the KGB to gather information about the U.S. Space Shuttle program, which was made relatively easy as such information was unclassified. The Buran orbiter design was selected in 1976 and was almost identical to the U.S. shuttle design. The design was altered in 1978, with the final design approved the following year. Initially, Soviet engineers had been hesitant to accept a design that was too similar to that of the U.S. shuttle design. However, wind tunnel studies had shown that the U.S. design was sound, and that it allowed for the military space missions required to counter the feared military use of the American Space Shuttle. Construction of the orbiters commenced in 1980, and suborbital test flights of a scale model were conducted in 1983. The first full-scale orbiter was rolled out in 1984. Developed in parallel to the Buran orbiter project was the Energia rocket. Initial work on Energia began in 1976 following the cancellation of the failed N-1 rocket and the Soviet lunar program. It was designed to carry the Buran orbiters, and it also could be flown with other payloads instead of an orbiter as well. As the Energia rocket was being designed, it was even determined that side-mounting the orbiter on the rocket would work the best, as was done with the American orbiter, which was side-mounted on the external fuel tank and solid rocket boosters. The Energia rocket design consisted of a core stage with 4 strap-on liquid propellant boosters, 2 boosters on each side. The payload could either be an orbiter or flown without an orbiter and instead a separate payload. The American shuttle orbiter and solid rocket boosters and external tank, on the other hand, were a single launch vehicle system. Liquid propellants, liquid oxygen and kerosene, were selected for the Energia strap-on boosters due to the lack of Soviet experience in developing large solid-fueled boosters. Liquid oxygen and liquid hydrogen were selected as the propellants for the core stage to pursue development of such technology to achieve parity with American rocket technology in that area. Soviet rocket technology in some respects was actually more advanced, and the intent was to build upon that in developing their own liquid hydrogen rocket engines rather than simply directly copying the American design for the Space Shuttle's main engines. Development of the core stage went ahead with fuel development problems being encountered, while the development of the boosters met with slow progress and numerous delays. The boosters were designed for reusability, with recovery parachutes being fitted, although transporting the boosters over land back to the launch facility would have proved difficult. The solid rocket boosters on the American Space Shuttle parachuted into the Atlantic after being jettisoned, which made recovery far easier. Numerous delays put the program years behind schedule, making the originally planned 1983 first flight impossible. The first flight of the Energia rocket was finally carried out on May 15, 1987, carrying the Polyus experimental space laser. The launch itself was successful, although the Polyus failed to reach orbit. The Energia project ultimately ended after the cancellation of the Buran project and later the fall of the Soviet Union itself. The strap-on boosters, however, were developed into other rocket designs. Meanwhile, development of the orbiters proceeded, and testing of mock-ups and work on the flight-worthy orbiters continued during the early and mid-1980s. A subscale model called the Bohr was tested on space flights in the early 1980s, and on one occasion, the crew of an Australian fishing boat witnessed a Soviet ship retrieving one from the ocean, confirming that the Soviet shuttle was a copy of the American Space Shuttle. In addition to several mock-up examples for testing, a test vehicle called the Buran Analog was built, which was a full-scale orbiter equipped with 4 jet engines. It was not intended for space flights, but rather for atmospheric test flights. It differed from the American Space Shuttle Enterprise test vehicle, which was unpowered and carried into the air on a modified 747 aircraft and released to glide to a landing. The analog vehicle, on the other hand, took off from a runway under its own power, was flown to a certain altitude and distance from the airfield, where the engines were shut down and the vehicle was piloted to a gliding landing, simulating a return from a space flight. Flights of the Buran analog vehicle began in November of 1985. At this point, the program had fallen years behind the Space Shuttle program, which had already been conducting space missions since 1981 with 4 space-worthy orbiters. Work then proceeded preparing for the first flight of the Buran orbiter. The first flight was planned to be uncrewed, with 2 types of flight being explored. A 3-day flight which would be a complete test of all orbiter systems, and a 2-orbit flight that could be carried out without all the orbiter systems being ready. That would be able to be carried out sooner and would be enough to prove critical systems like the automated launch, flight, and landing systems, as well as being able to maneuver in orbit. 2 of the cosmonauts assigned to the project insisted that the flight should be crewed, but the officials in charge agreed that it should be an uncrewed 2-orbit flight. The first flight was initially scheduled for October 29, 1988, but a computer problem caused a postponement to November 15th. The launch and ascent were successful, and the orbiter separated from the rocket and used its maneuvering engines to enter a higher orbit. After completing 2 orbits, the orbiter fired its maneuvering engines to leave orbit and re-enter the atmosphere. The orbiter made a successful landing at the Baikonur Cosmodrome. This was the first completely automated spaceflight and landing of a spaceplane, whereas the first flight of the American Space Shuttle in 1981 was carried out with a crew on board. Despite this success, the Soviet Union was in its final years, and funding for the program was dwindling, and was officially canceled in 1993 by the Russian government. At the time of the program's cancellation, it was planned that 5 orbiters were to be built. However, only 3 were completed, with the other 2 left unfinished. The orbiters were designed for 100 flights. They could carry a crew of 4, a pilot and a co-pilot, and 2 EVA or payload specialists, although up to 10 crew could be carried, using additional seats in the lower deck of the crew cabin. Like the American shuttle, the heat shield consisted of thermal protection tiles covering the exterior of the orbiters. Flights were planned to last 10 days and were extendable up to 30 days with extra supplies on board. Also, like the American shuttle, the orbiters had a large payload bay with large doors that could be opened when in space. It also had a docking adapter for flights to the Mir space station. One major difference when compared to the American orbiter was that it had no main engines, only smaller maneuvering engines for use once separated from the inert gear rocket and in orbit. 2 orbiters were completed. Buran, which is Russian for snowstorm or blizzard, which was the only orbiter to fly in space and was flown on the 1988 flight. Unfortunately, it was destroyed in a hangar collapse in 2002. The second orbiter, Burya, meaning storm or tempest, was 95% complete when the program was ultimately canceled and is currently in an abandoned hangar at the Baikonur Cosmodrome in Kazakhstan. The remaining 3 orbiters were only partially completed and unnamed when the program was canceled. The Buran program, despite its great potential when compared to the American Space Shuttle, was plagued by delays that put it several years behind in development, caused in part by the development of new technologies that were required. Even if the program had led to regular crewed missions, those flights would have taken place well into the 1990s, at a time when the American shuttle had been in operation for many years, and it's difficult to speculate how long the program would have lasted. Consider the massive funding problems the Russian space program encountered in the years following the fall of the Soviet Union in 1991. On the other hand, if it hadn't been delayed by development issues and later funding problems, it might very well have been as successful as the American Space Shuttle, which flew from 1981 to 2011, making 135 flights. Indeed, it would have been interesting to see Buran shuttles operating in parallel with the American shuttles. However, despite the failure of the Buran program, the Russian space program has continued operating the Soyuz spacecraft, which is currently being flown on missions to the International Space Station, along with the American SpaceX Dragon spacecraft, which interestingly returns to Earth by parachute and splashing down for a water landing, as did American spacecraft in the pre-Space Shuttle era. Thanks for watching. Like and subscribe. And always remember, when the future was cool.